Hi guys, greetings once again. So we continue our series. Today we'll be talking about pseudocode, flowchart, algorithm, basically everything that makes up your whiteboarding process. So let's get to it straight up. So what is pseudocode? Simply, pseudocode is what you may call fake code. That's what pseudo means. Pseudo means fake, so fake code. Now, as you can see on your screen, it says pseudocode is not a programming language. This is just a simpler version of a programming code in plain English. That is, you just have a simple version of your code in plain English because it helps both programmers and non-programmers to understand the code. Pseudocode represents how you think, and it makes your solutions readable to others makes it readable to others even before you write out the codes. It's more like a syntactic representation of the program, but it has no syntax because, like I said, it only represents how you think and it can be readable by others. Pseudocode also makes programmers and even non-programmers to understand your code because it translates the instruction into plain English that can be executed after you've turned it into a real code. So in simpler version, pseudocode is code in plain English. That's just it. When you say pseudocode, fake code or code in plain English before you execute it in any kind of language, maybe C, C++, C#, or even Python. So let's proceed. Why would you use pseudocode? Pseudocode makes it easy for you to write your logic in plain English language. It also helps you to break large problems into chunks, into smaller sizes. Also, it helps you to find solutions quickly. So when you can break your problem into smaller size, it becomes very easy for you to find solutions to them. Now, how do you write the pseudocode? Or some rules. So some rules, though it's not set in stone, but so that you can understand it easily, always capitalize your key commands. Also, write each statement on one line. Use indentations just like you would do in real code. And most important, be specific and ensure that your pseudocode is simple and understandable. Next, what is an algorithm? Algorithm is basically set of instructions for solving problems with a step-by-step breakdown. That is to say, an algorithm is a set of instructions that you would use in solving a problem. So let's assume I want to open up a bottle of drink. The first thing I need to do is to get my drink from the refrigerator. Secondly, I get the opener. Third, I open it up. Can you see that? I've been able to do that in steps. So instead of saying open the drink, I've been able to show you the steps that I would take in opening that drink. So that is your algorithm. Algorithm shows you the step that you would take to solve a problem. Don't worry, this will become very clear when we get to drawing up the flowchart diagram. But in your head, just look at algorithm as that step-by-step process to solve a problem that is watertight. What is a flowchart? Now, a flowchart is a type of diagram that represents visually your workflow or the process using a set of symbols or icons to denote different actions. So it shows you different actions, different decisions and steps that you would take, showing you the process through an arrow that describes the direction of the flow. Flowcharts are important and they are used in so many different professions, not just in software engineering alone, because they can help you to manage a workflow or design a proper process. So why use a flowchart? Like you know already, just like your pseudocode that helps you to show your program in plain English, a flowchart provides you another way of approaching or understanding a workflow. So let's look at it like this. Flowcharts and pseudocodes are brothers. But pseudocode, you would use pseudocode to explain your code in simple English language. But in flowchart, you're not speaking English, you're using diagrams, you're using shapes to denote your workflow. Now, another benefit of this is that if you do your workflow very well, your flowchart, it can be understood by people who know nothing about web development or software engineering. And it will also make it possible for developers like you to also understand what you are doing or what you aim to achieve with your code. Now, flowchart symbol. Remember I told you flowchart is important, but then unlike pseudocode that we try to speak basic English, in flowchart you're using symbols. And this type of diagram is very versatile, and like I said before, many professionals tend to use it. Now, due to so many numbers of industries using flowcharts, there are many types of symbols and styles that have been created for specific industry. But the most important thing you need to know is that a good flowchart symbol should use the ISO 5807 symbol set. And they are well known, that is why they use them, and often used in the technology industry like we are in, software engineering. And what are these flowchart symbols? Here they are. The first one is your flow line or arrowhead. This is used to show order. So you're trying to say from this step, go to this step. The next one is used to show terminal. It tells you this is where something is starting from and this is where it is ending. It's like a circle, but it is stretched in the middle. Okay? So it's used to show terminal. So the beginning of something, the end of something, or telling someone to start. The next one is your rectangle. A rectangle is used to denote process. So if you have a process in your flowchart, you use a rectangle. A process could be anything that needs to be done, before you progress. So it could be editing a video or setting a variable to hello. That is a process. A parallelogram is used to show data, input and output. So if you want to show input, you use parallelogram. If you want to show output or result, you also use parallelogram. Your kite is used to show decision or conditionals. So when we talk about decisions, could be something like if. When you use the if statement, you're talking about conditionals. You use them with the kite. Or you use them to ask questions that determine the next step that will be taken from the question. So if Precious is a boy, print boy. If Precious is a girl, print girl. Alright. Now, these are the less important ones, or the ones you won't use a lot, but let's just run through them. So this one is used to denote documents, so represent a document. Then you have this one, which is used to show current process, but this is defined elsewhere. Then you have annotation that shows information about a step. Replaces long or confusing line, use a letter to reference, that is the small circle. Then you have the off-page connector and the data file or database. So like I said, we will be using the arrow, the stretch circle, the rectangle, the parallelogram, and the kite a lot. Now, let's go to business. I love practicals a lot, like you must have known already. So we'll be doing the practicals with what is called Fizzbuzz. So Fizzbuzz is a game that deals with division or modulus. So when a number is divided by 3 and the remainder is 0, you print fizz. If a number is divided by 5 and the remainder is 0, you print buzz. And if a number is divided by 3 and 5, that is divisible by 15, you print Fizzbuzz. So in programming, there is a word called modulo or modulus, which is represented by this sign. So in modulus is like your normal division. So when we say 3 divided by 2, right? You get 3 divided by 2 is 1 remainder 1. So this 1 that is remainder is your modulus. Anything remaining is called modulus. If we say 4 divided by 2, you have what? 4 divided by 2 is 2 remainder 2. This 2 is the modulus. Anything that is remaining when you do your division is your modulus. 3 or 4 divided by 3 is also 1 remainder 1. So 3 will go into 4 one time. Then there will be a remainder of what? 1. All right? So that is modulus. So when we do the modulus, we want to have something that is remaining only 0 for the conditions to match. I just duplicated that so that we can do it at the bottom here. So remember I told you we can show our figures or we can show our process using pseudocode or flowchart. So we are going to start with the pseudocode before we go into the flowchart. So first, let's represent this problem using pseudocode so that the programmer will be able to start developing quickly just by looking at it. So how do we proceed? To do this in pseudocode, we are going to use what is called if and else statement. So we have to test. And remember, one of the important parts of pseudocode is that any important command should be in capital letters. So we start with if. So if number. So we are doing these numbers between 1 to 20. All right? So we are checking between number 1 to 20. Between number 1 to 20. So if number, so the first number, maybe number 1, modulus 15 is equal to 0. What do? The answer here says we should do what? We should print fizzbuzz. So we are going to do that. Print fizzbuzz. The next one says if number modulus 5. So if number divided by 5 and the remainder is 0, we print what? We print buzz. So this should be else if. You could use if too, but let's use else if. Then else if number modulus 3 is equivalent to 0. Here we print fizz. But also there should be a last condition. What if we do it and the remainder is greater than 0, So else, we could leave that one as it is. So else, it will always revert to this. Print, let's say, not valued, or let's print something. Not counted. So let's just leave it as not counted or print error. Yeah, let's just call it error. Now, so you can see it. We've been able to describe what we want to do here using pseudocode. So if you look at this and you already understand programming, you will be able to convert this to a real code by just looking at it. It almost looks like a code, but it's not a code. It's just English language. We are just telling you if number is divided by 15 and is equal to 0, print this. Else, if the number divided by 5 and the remainder is equal to 0, print buzz. Else, if the number divided by 3 and the remainder is equal to 0, print error. Print fees. Else, print error. Now, let's move all this and turn it to a flowchart. So remember I told you, I'm going to paste that here. Remember I told you that you can use pseudocode to show your code in English language. But also, you can use flowcharts to also make it more descriptive. So let's begin. The first thing you need to do is, from the previous slide I told you, for input or to start your process, you use this stretched out circle that says, then you name it start. So anything you write inside is the algorithm. So now that you understand, you use your flowcharts with algorithm. The flowcharts only takes these symbols, but when you start writing inside of it, that is your algorithm at work. So we want to convert this pseudocode into a flowchart. The next step for us is to use an arrow. So the arrow is used to describe the next step or the direction of what we are doing. Okay? So when you start, what is the next thing? You're taking inputs. And your inputs can come from anywhere. It could be from a loop. But whatever it is an input because it is sending in these numbers. So what numbers are we working with? Remember, we said number 1 to 20, okay? So let's say input number 1 to 20. So it's a loop. So just say input and loop through number 1 to 20. So it's going to loop, it will start from 1, 2, 3, and so forth. So now that we have our loop coming in from the input, what is the next thing? We need to test the condition. And what are the first conditions we are testing? We are testing if number is this, okay? So to do that, imagine how it looks like. That means when the first number is coming, it will go through this first condition, if, right? So we can actually move this to the side because I can already imagine how it will look like in my head so that you will understand it. Okay? So if our input is starting from here, the next thing is we need to test the condition. So we are testing our first condition. And what is the first condition? The first condition is if number modulus this, okay? So let me copy that. And how do you test condition? You use kite. So I'm going to drop the kite here. Let me stretch it out a little. Yes. So the first condition is this. If number modulus 15 is equal to 0, what are we supposed to do? We print buzz, right? We are going to print fizz buzz if number divided by 15 and the remainder is equal to 0. So how do you print results? You also use the same input because this is for input and output. Okay, so we print what? Fizz buzz. And don't forget, if the condition is true, it means the program is going to end somewhere, right? So we have to end it. Down here. And what do you end with? You end with the same one you started with. This symbol is for terminal. So starting and ending. Now we have our first condition. So when one goes into it, blah, 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 one goes into it, if one does this, print feasible. But then there's an issue. So let's say we start with 1, right? So number 1 comes in. Number 1 divided by 15. As you can see, the remainder is big, like it's more than 0. So it does not match this condition. So we need to take control of that. That means it has to go into this next condition, else if. So now, for it to print feasibles, it has to be what? It has to be true. And how can it be true? We have to note it there. True for it to print feasibles. Okay, so it tells you here that if it is true, it's going to print feasibles. All right, but what happens if it is not true? Good. What happens if it is not true? Sorry, I have a little bit of symmetry issue here. I like these things to be, well aligned. Yeah. So what happens if this condition is not met? Then it leads us to another condition. We have to test again. That's just it. If a condition is not met, you have to test it again. And how do you test again? We have to proceed. So now that we've gone inside, this condition is not true. We have to draw an arrow that tells us that the process has to continue. It cannot end because it's not true. So if it is false, now that this condition is false, we have to check the other condition, right? Just to save time, let me just copy all these guys out. Let's elongate it and create all our conditions. Let me put this one here. Because we have 4 conditions. The 4 conditions are this: if, else if, and else, okay? So this one is if number modulus 5. And this one is if number modulus 3. And this one is if number modulus 15 is greater than 0. Let me take out the if. We don't need if there again. We know that is a condition already. So, or modulus, the 3 different modulus. So modulus 5 or modulus 3. All right. Reduce the font size. Good. So that it fits in. So let me take out if here because we already know that these are conditions. All right. We know that they are conditions. The symbol already tells us that it's a condition. So anytime you see this is a condition, if this or if this. Now, we have to also note that our conditions may not be true till the end. So we have to do that. So why I'm putting the arrow is to tell it that if a condition is not met, you go to the next one, okay? So it has to be false for this one to come here. And it has to be false for us to get to the last condition here. Just be patient, I'm trying to do this so that you would be able to understand and see what I'm doing properly. That is why I'm taking my time to do this. So now, if the first condition, the first number from the loop goes in here, if it is true, it will print feasibles. But if it is false, it has to come here, right? And when it gets here, what happens if it is true? Good question. We have to show that also. Sorry. Let me just create every one of them to save us time. Yeah. Now let me create the outputs because we'll be outputting some results. So why not just do it now? I'm going to talk about them, don't worry. So from our condition, if number modulus 5 is equal to 0, what is it? You should print buzz. I believe you're getting the hang of it now. And this one should print fizz. Okay? And this one should print what? Error. So you see, I'm actually converting this to this. Now also remember that we also have our results. Okay? We need to end the process. So wherever the result works, we have to end it. Okay? Almost done with it. All right? And the last ending. Okay, guys. So now it has to be true to print this. And it has to be true to print this. And the last condition has to be true for us to see error. All right. So now we've been able to convert this to this. So now let's start. We start the program. When the input or we loop through a number, we start from 1. But 1 modulus 15 is greater than 0. So it cannot be true. So instead it proceeds, it's false. It goes into the next condition. Inside of this next condition, it checks again. 1 modulus 5 is equal to 0, is not equal to 0, is greater than 0. It's false, it proceeds. Same thing, 1 modulus 3 is greater than 0, is not equal to 0. It proceeds till it gets here. So 1 is going to actually output print error for us. Same thing when you do it for 2, 3, 4, 5. So let's assume we have 2. 2 divided by 15. The remainder is greater than 0. This guy cannot be true. So it has to come here again. Same thing. 2 divided by 5. The remainder is greater than 0. It has to proceed till you get to the last part. Okay? So, but now you need to understand something, that our number is a loop. So every time the number is always coming in. All right? So we have to note that the number is always coming in, which we have done here. The number is coming in from here. Look at the arrow. So the number comes in, it tests this first condition. If it's not true, it proceeds. But then the sequence has to be circular because it's a loop. So 1, we go through everything. When it gets here, it goes back to look for 2. Circle through it to 20. So we have to note that by using this. Okay, so we connect this to the ending here. So I want to make it yes. I think it looks pretty enough now. So what this is telling you now is that if 1 enters here, it will check through its condition till it meets anyone that is true for it. Then it will print the result. Then after 1 is done, it will go again from here to pick 2. You see, it will check again for 2. It will go back again, 3, go back again, 4, 5, till the result it can't check anymore. Then we are done. So basically, we've been able to convert this to this. So you can check it out and understand it. And it's looking like this, but like I said, a flowchart is actually you representing your work. Let's see what other people will represent theirs with. So if we go to Google and let's assume we want to check for other people's flowcharts. Let's check for Fizzballs. Let's check for other people's Fizzballs. Let me open up a tab. So if I check for Fizzballs flowcharts, let's see what other people came up with, and let's see how it looks with mine. What my point is, I want you to understand that it may not look the same, but the point is, when you look at it, even as a non-developer, you should be able to understand it. Like when you look at mine, you should be able to understand what is happening. Let's check other people. So you see, there are other different results, and they look very different from mine. So you see that it's a matter of your own idea. You bring it to life using your flowchart, and you can be able to explain it, or people will look at it on their own and they should be able to explain it. So this is my flowchart, and I believe that you've been able to understand how I was able to come up with this process using the algorithms inside. These are the algorithms, the tests, and also using the flowchart symbol. So this is a flowchart and algorithm, and this is a pseudocode solution. So I was able to use pseudocode to solve this Fizzballs problem. So I use pseudocode and I use flowcharts and algorithm. So ladies and gentlemen, that is that for us today on pseudocode, flowcharts, and algorithm. Basically, all this makes up your whiteboarding process. So I thank you for being here. I'll see you in the next one.